So let's take a look at the stoichiometry problem. This is actually one that we'll do in lab. We have sodium carbonate plus hydrochloric acid, so HCl is hydrochloric acid. We form sodium chloride, water, and carbon dioxide gas. Whenever we do stoichiometry, first thing to do is make sure it's balanced. So, and again, one thing about that, if you don't put coefficients in front of these species, it's understood to be 1. So basically, I have 1 mole of sodium carbonate plus 2 moles of hydrochloric acid will give 2 moles of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide gas. So all these chemical reactions are written in terms of mole to mole ratio. So the first part is how many moles of HCl, hydrochloric acid, will react with 1.5 moles of Na2Cl3. So a couple of things. Write down what's given, which is 1.5 moles. Sodium carbonate. I need to figure out moles of hydrochloric acid that will react with it. So, what I have to look at is the mole to mole ratio. I know that 1 mole of this will react with 2 moles of HCl. I can write that as a unit factor if you want to. We can write like this. We can say that 1 mole of Na say 1 mole of Na2CO3 over 2 moles of HCl, or I can write the reverse. So again, I need to be left with moles of HCl, so I'll use that second unit factor. My moles of sodium carbonate cancel, and it's going to require 3 moles of hydrochloric acid. So let's continue with the second part. In this case, it's how many grams of NaCl, that's our product, sodium chloride, will be produced from 1.75 grams of sodium carbonate. So whenever they give it to you in grams, convert it to moles, because everything works in terms of mole to mole ratio. So you look up the molar mass, it's 105.99. So again, first thing you do, to give it to you in grams, convert it to moles. Now we can look at the balanced chemical equation. 1 mole of this, 1 mole of sodium carbonate, will produce 2 moles of NaCl. So I'm going to put 2 moles it's a 2-to-1 ratio. So again, each balanced chemical equations may be a little bit different. Now the very last step is I need to figure out grams. So basically, I'm going to convert moles of NaCl to grams. I'll look up its molar mass. Remember, molar mass is always per one mole. So it's going 58. Pay attention. This too has nothing to do with this. It's always per 1 mole. This is for the balanced chemical equation. Molar mass is always per 1 mole. So when I do that, my yield would be 1.930 grams. One thing to note, whenever we do calculations, it's always theoretical. This is my theoretical yield. So theoretically, I should get 1.930 grams. In reality, you're going to get less. So when you're doing this experimentally, it's always going to be less than your theoretical yield. So the second part is the actual amount produced was 0.979 grams of NaCl. I want to figure out what my percent yield is going to be. So percent yield is your actual or experimental yield divided by theoretical times 100. So the actual yield in this case was 0.979. So everybody's experiment is going to be a little bit different in that. Your theoretical yield is with the calculations we just did, and that was 1.930 grams and times 100. So when I do that, I'm going to end up with 50.7%. So again, your theoretical yield is the calculations. Your actual yield is what you actually physically get in the experiment.